your best question.
Or
Okay, so what are we going to do? Got to start again. I forgot to hit the record button, guys. Sorry. So what are we going to do to turn pre-image 1? And again, we're just going to say the pre-image like Jalen. That was a good question you asked a minute ago. How do I know which one's the pre-image? Alphabetically, whoever's first. How do I put image 1 on image 2? So the best case on this one is we're going to translate it. And I'm going to ask you guys, when you do this, is just take a second and draw the translation line. You have these papers. You're going to say it's simply a translation up and to the right.
Now I do what I want. Now I do
And
it.
you're going to say it's congruent. Okay, so let's do number 2. We'll do number 1, 2, and 4, and then y'all can try or 1, 2, and 3, and then y'all can try 4, 5, and 6. So number 2, how am I going to take image 1 and turn it into image and prove that they're congruent? First of all, do they look congruent? What do y'all think?
Yes.
So we'll put our first guess is it is congruent. If I could spell it would help. Congruent. What would I have to do to image 1 to make it the same?
rotation.
So I'm gonna have to rotate it. About how many
90
degrees?
degrees clockwise.
Counter.
Counter.
Wait, no.
I like your thought. It's actually 120 degrees counterclockwise or 240 degrees clockwise. But I'm not really going to work.
20.
I'm not going to complain if you just tell me rotation. Okay. So it's a rotation, and what else would I have to do? So if I rotated it, now I'd have 2 shapes that kind of go the same direction.
And then reflect.
I could reflect or
Translate.
Yep. Either way would work. Okay. So again, multiple ways. You're going to have to rotate somewhere, but you can either reflect or translate. Either one of those would be considered correct. All right, last one. What would I have to do on number 3? Are they congruent?
Yes.
Yeah, I agree they are. So what would I have to do?
Reflect.
That's a simple reflection. And if you can, draw that reflection line would be right there. You don't have to draw the reflection line, but it's great to kind of starting to get used to being able to do that. All right. Now that we've got that kind of talked up and kind of explained, I want you guys to try 4, 5, and 6. I'll put them on my screen. If you don't have the paper printed, that's fine. We can deal with that another day. But I want you to try those 3 problems. I'll give you about 3 minutes, and then we'll come back.
What if they're not congruent?
So the second half of the lesson today is we're really going to take a look at, now that I have these, I can prove they're congruent by using translation. How can I compare the parts that are the same? Okay, and using that comparison, find missing measurements. So a little bit of information, a little bit of vocabulary. We've got the concept of corresponding parts. So let me draw you a little picture of what that might look like. So for a corresponding part, you would say, okay, I've got shape A, B, and C, and shape over here. They're similar. They're not the exact same thing. Well, let's say they're congruent. Let's just say we'll do exactly the same. Okay, so now that we know that this is shape D, E, and F, if I translated these 2, we could say they're exactly the same. So now, what parts are congruent to each other? What lines are congruent to each other? AC is congruent to what?
DF.
DF, that's right, Gracie. All right, was that not Gracie?
No.
Oh, I'm sorry. That was Georgia?
No.
Riley? I'm so sorry, man. I'm not doing so well. It's been too long since I've heard y'all's voices. All right, what is CB congruent to?
FE.
FE? All right, I will tell Miss Pritchett if anyone can tell me what that is the atomic symbol for. I will email her right now. Iron, yes. All right, Jalen, I think I heard you first.
Yeah.
I'll tell her you were listening in class.
Well, I don't have
All right. I'll tell Miss Adam then. How's that?
Oh, Thomas Pritchett, I said it. She'd be
All
proud.
right, I'll pass on that they knew. I'll pass on. She got it. And then DE would be congruent to what line on the other side?
AB.
Yep. So we would say, so these are corresponding parts. They're the exact same. So that's that definition. This symbol is just a quick way of instead of writing out is congruent to, an equal sign with a little squiggle over the top of it is the same thing as is congruent to. It saves you guys a whole lot of handwriting. I don't know about you, but I'm glad mathematicians are mildly lazy and always come up with new symbols to write to keep us from writing very much. All right. So now that we've kind of got that down, what this part says, and this is a part of it, this is also in your notes. If a figure are congruent, so if we can flip them over, we can translate them, we can prove they're congruent. Their corresponding sides are also congruent. Okay? This is kind of the basis behind the triangle theorems we worked on. Okay? This is the basis behind the triangle congruence theorems. Like SAS, right? Angle, side, angle. Remember all those we talked about in the previous triangles unit? This concept is the basis behind that. So these kind of look really similar to each other in that respect?
Yeah.
Okay, so now that I'm proving that they're congruent to each other, so angle A is congruent to D, B is congruent to E, F is congruent to C, and so on, all the lines we kind of talked about on the previous line. This leads you into this idea. Okay. You guys kind of knew this stuff even before you got started because we already talked a lot about this. Yes, Nick.
May I use the restroom real quick?
Why didn't you use it when we had a break, man?
The break was only like 2 minutes.
It's like 4.
4?
You're really arguing with a math teacher, really, by numbers. Go, hurry up. All right. Catherine's going to get a kick out of that one. She's going to get a kick out of that argument. All right. So now if we take a look at this one, the first thing you want to do when you have something like this is match the tick marks up. Okay. So if we take a look, this is in your notes. You'd look at this and go, okay. You say, okay, this one has 3. IH is congruent to what one?
JK.
JK or LK in this case. Not the same spot. So if you see that it's not 1 goes with 1, 2 goes with 2, and 3 goes with 3. So you can see the angles are all corresponding. 2 hash marks says these two are congruent to each other. I and L. J and G because they have 1 line, and K and H because they have 3. And the same thing with the lines. I know this is probably a little bit of a review from Miss Houston's class last year and Miss Hill. Is that right?
No.
I don't remember.
You don't remember? Well, then it's a good review, nevertheless. Okay? That these two sides are congruent to each other. Really, that's really what I want you guys, now that we figured this out, what are some of the pairs that are congruent on this one?
B.
Let's start with the angles.
B and Q.
Okay, so that's Everett. Somebody else.
D and R.
R and D. Oh, and then
Okay, D and R
P
and
C.
and P and C. A bank. Okay, now that that's a horrible R. Now what about the lines? What about the sides? Now other people that have not talked, really funny, Jalen, stop. What about the line sides? What about the sides?
3 and the 3.
Yeah, but what are the names for that? PQ and what?
SQ.
BC.
BC is right. Good job, Nick.
R and D.
What about you, Miss Emma? Pick a pair.
I didn't realize I was on mute. Q and R.
Oh, all right. Q and R, and what else?
Is it B and D?
It is BD. All right, Alexis, you're up.
For what? Didn't they get all of them?
Nope.
R.
They did this one and this one. PR, public relations. And what else?
Birds chirping.
Yeah, I muted Ethan, don't worry. What, Alexis, what's the other pair? I didn't hear you earlier.
DC.
Thank you. A little bit of comic book action for you. All right. All right. So we kind of get the idea of how this works. Now, here's the neat thing about it. Once you've proven they're congruent to each other, you can take some information and go, okay, now that I've proven they're congruent to each other, I can rotate them, I can flip them, I know that. And I write my congruent statements and go, okay, I can figure out my line sizes. So if I would look at this, I know they're congruent because I can look A, B, and X, Y are congruent. B, C, and Y, Z, X, Z, and AC. They're all congruent. All the angles are equal to each other. So now the next step is, okay, what transformation maps those two onto each other? So that's the next step. That kind of combines unit 1, lesson 1 we're talking about, and the lesson 2 we're kind of looking at. So we'd say, okay, do I need to change the orientation of the triangle? Are they flipped? So my idea is I'm going to flip it over. So I'm going to take that first A, B, C and flip it over the x-axis. So that puts it over here. My new A is here, here, and my new C is right here. So it's A1, B1, sorry, this should be B, sorry, B1, A1, and C1 are here. Now what do I have to do to get it to match? I've got to translate it. Yep, that's exactly what I'm looking for now. Now that I have a coordinate plane, that helps me see that a lot easier than just kind of guessing and telling you the steps. So the transformation maps the two is a reflection over the y-axis and a translation 2 units down. So let's try this next one. It's telling me they're congruent. There's a proof statement right there. This is the given. If you think back in the proof theory we talked about, I need to write the congruent statement. So there's several pieces here. What angles are congruent to the other? So angle M and what?
Angle M and N.
Not N. They're not on the same triangle. They're going to be on different triangles.
Oh, M and
R.
On you.
Not
S.
R.
S.
S. So if you look real quickly, this one's, you're going to have to do a little bit of thinking here. So it's going to go, okay, M is here in the corner. It's across from the hypotenuse. The hypotenuse is our longest side. So S is the one that's across from the hypotenuse. So it's M and angle S. So what is R congruent with?
L.
T.
N.
Oh, snap, my bad.
So if you look at where R is above the angle. So remember, this is flipped over, so now it's below. And that leaves the last one as L and T. You all seeing where I'm getting those?
Hmm.
Yes, no, maybe.
Yes.
Yes.
Okay. So now, are the sides congruent? So what sides are congruent to what others? So if we got the sides here.
TR to LN.
All right, so TR and LN, those are the hypotenuse. Nice job, Nick. Who's got another pair?
MN and RS.
Very good. Way to go, Alexis. Or was that Kiara? I'm sorry. I've got my video closed so I can write on my screen. And that leaves our last pair as ST and what else? ML. Okay. So now that I've got that, how can I get these two to translate on top of each other? That's step 1. What's step 2? What am I going to have to do? Here's my y-axis. What am I going to have to do?
You have to translate it.
Okay. How much?
Wait.
So if I move M,
Up
where do I
9.
have to move M to? Over how many? How far do I have to move it? I agree, it's translate, Nick. That's one way to do it.
Over 5.
6, but that's close enough. Right, 6.
The C.
It's okay. It's tiny handwriting, I know. Horrible handwriting on my screen. Whenever I have all of you open, that makes my writing look really bad. Write 6 places, so 1, 2, 3, 4, 5, 6. Then what would I have to do? Let's pick on somebody else. Riley. What would I have to do next? So now it's over here. N is here, M is here, L1, M1, and N1. So what do I have to do now to get on top, to be on top of the other side?
Move it, translation.
If I translate it, it's still going to be pointed different directions. How do I get it to
R
turn over?
Okay.
in a
Rotation.
Rotation won't work because then it's going to turn it. So it's going to say if it's right now, it's like this. If I rotate it, it's just going to move in the same spot. It's going to change the orientation. So my best part is to reflect across what axis, Riley? Across our x-axis, right here. Okay. So if I flip it over, I can get them to land on top of each other. And like you see, there's the answer. Okay. They may have it slightly differently. They said reflect, then translate. Either way works. All right. So if I know these two angles are equal to each other, now here's my next piece. If I know the figures are congruent, I know B, C, and E, and D, F, and G are congruent. And it tells me angle C, E, D is 50, right here. What is F, G, D? What is this angle? It's the same thing. If you go back to parallels and transversals, this has a lot to do with it. Okay. So, and Nick's right. If you take a look, I'm pretty sure that was Nick. If these two are congruent, okay. If these two are congruent, if you look at the same spot on the new triangle, it's that same one, it's the same 50 degrees. Okay. All right. So that kind of walks us through a lot of the pieces. You can jump past this stuff. Let's have you try this one. What is the measure of angle X? Georgia, I'm going to ask you in just a second.
Oh.
Just thought I'd let you know. All right, Georgia, you think you got it?
I think so, but I'm not like super sure.
All right, we'll take a guess and we'll work from there.
Okay.
What do you think it is?
145 degrees.
So it's 145 degrees. That's right.
Okay.
Now, what is the measure of the angle X? That's exactly it. Now, here's the really cool part. Since they're congruent, that one's 90, that one's 70. This one's length is 3m, and this one's length is 4 meters. Everything will be exactly the same in just its mirrored location. So what you do is you figure out, okay, what happened? Is this been reflected, translated, rotated? In this case, it's been reflected across the line right here. So if it reflects, all we have to do is figure out which one is the opposite side of where it used to be. So if it's my hand, the opposite side is right here. So these two, the thumbs are on opposite sides of each other. All right, now that we've kind of got that worked down, okay, that's the idea behind it. We're going to jump past this. What we're going to do now is take a look at that same, I'm going to pause our recording for Cap.